Good afternoon, everybody. Thank you for joining us on the Break Free with Triple C webinar. For those that have joined, a big thank you for taking the time out in what I assume is an ever busy schedule to sit down and listen to me talk about one of our latest gas detectors, the Triple C. So we'll get started and we'll jump into the first sort of section that we're going to be talking about. It's kicking off with our agenda. So we're going to take a look at historic approaches to personal gas detection and calibration within the marine industry, moving on to digitisation and innovation, following on with sort of a bit of a deeper dive really into innovation and how the new technology is coming through, specifically in the personal gas detection market. An overview of our adaptation of such technology, how your customers, your vessels, depending on who we've got on the call, can benefit, and then talk about some of the cost savings that can be attained as a result of adopting Triple C. And then we'll finish off with any questions. So yeah, we'll jump into it and we'll get started. So historic approaches to personal gas detection, and before we jump into what's actually on the slide, I thought it'd be useful to share a little bit more about Martek and how Martek was born. So our company was founded as a result of manufacturing in-house fixed gas detection systems. So you could say that fixed gas detection or gas detection as a principle is sort of Martek's underpinning theme. It's something that we've worked with and that we've understood for a number of years and we've watched evolve over time, and this is what we're talking about here on this slide. So many moons ago, the first need for gas detection, people carried a long wick that was carried by hand, and that long wick enabled them to look for gas pockets in the confined space that they were working on. There was then, and this was more commonly used in mining, the introduction of canaries. So they have a similar nervous system to that of a human, and if the canary was exposed to gas, the cage would start to shake, and if the canary stopped chirping, then it was time to get out. Thankfully, we've moved on quite considerably since those two practices were commonly used, and technology was built around the flame light. So protected by a glass flame arrestor. It was an open flame burning, which indicated whether or not oxygen or methane alike was present. Technology evolved on once again. You'll see a bit of a theme here, and the catalytic sensor was born. So this was the first sensor type used in what we know as a modern day gas detector, and it just worked on the principle that when the sensor was exposed to gas, the sensor, there's a little pilaster inside it, would heat up when the gas was oxidized, and basically highlight to the user that gas was or was not present, depending on the type of gas. Modern technology, so sort of 2022 onwards, we've moved on from catalytic sensor technology, certainly here at Martek Marine, and we now have adopted highly sensitive technology that comes with an array of different sensor options, which you'll find in the Triple C when we get on to talk about it. In addition to the sort of ever-evolving way of detecting the gases themselves, there's also been quite a shift over the past few decades in how gas detectors were calibrated. So traditionally, gas detectors were placed on board vessels. They were calibrated by shore-based service providers, meaning that the detectors were sent back to land. A service company would do the needful. They would check they were working via calibration, bump testing, and do any necessary maintenance that may include battery changes, sensor swap outs. As you can imagine, this can be quite a costly process. It's not cheap shipping things to and from a vessel, especially if you've got vessels trading in difficult ports. So companies were spending a hell of a lot of money in order to be able to maintain and calibrate their fleet of detectors. In addition to that, there's the downtime that comes as a result of the units needing to leave the vessel. So companies were faced with the dilemma of either being short of critical safety equipment on board or having to buy duplicate units for as and when the calibration anniversaries came around. So that was the sort of the first model that was used. Probably around 10 years ago, Martek was one of the leading companies that brought the onboard calibration solutions to market. So taking away the pain that technical managers were facing, having to arrange the logistics we've just mentioned of getting detectors to and from shore, we equipped vessels with the means to be able to do the calibration themselves, which was typically done so via a calibration station, dock. There's a couple of different names for them. And connecting the station and the detector to a cylinder of calibration gas via what we sell as called a demand flow regulator. The industry was, if you like, revolutionised by the technology coming into play. We saw more and more customers, certainly ourselves, adopting it as it enabled the vessel to become independent from the need to have third-party intervention. They could do everything themselves. They could fault diagnose, swap out the sensors, and get all the relevant certifications that they needed to be able to pass vetting and sire inspections. But that's the historic ways of calibrating, and through the introduction of CCC, we've changed it once again. And we'll touch on that in a second. Another sort of area that I thought it'd be relevant to touch on today, just for those of you that are not as heavily involved in this area of the industry as we are, or don't get exposed to it as much, just like what is happening with the CCC and with gas detection solutions, or different gas detection solutions alike. The broader industry is digitising, it's innovating. We've got a couple of examples here on screen of how navigation's changed in recent years. So we've gone from dead reckoning and celestial navigation to radar and to the new modern day GPS-based systems. The propulsion's changed. I'm not sure if any of you have seen the post by a couple of different shipyards of late that are talking about revolutionising wind technology, when if you take a step back and think, this is how ships used to sail. It was either paddles or sails back in the 19th century. And it wasn't until the second half of the 20th century that diesel engines became common practice. And now we're seeing a shift to wind, if you like, or LNG, electric, nuclear powered engines. There's a big topic going on at the moment about what the new fuel is going to be, what alternative fueling options there is in the industry. And there's lots of other examples, but I think it was pertinent for this particular webinar to show that it's not just safety that's changing and that is evolving with new technology. Everything to do with modern day shipping is changing and improving, hopefully for the better. So where do we come into play? Well, we, like with the onboard calibration solutions, we're very much on a venture towards innovating the personal gas detection market. We want to bring new technology to the forefront of people's attentions, and to ultimately really improve the service of those using multi-gas detectors. They are a critical piece of safety equipment. I think the SOLAS regulation that mandates them is a 170 something page document, so it is important, but in our opinion it's equally as important that we innovate and that we move with the times, like we've seen with the examples of navigation and propulsion. So this is where the CCC comes in. So unlike other detectors in the market, and we still sell some of them, the CCC adopts cutting-edge infrared sensor technology that enables 3 years worth of battery life, 3 years worth of operating without the need to calibrate. and 3 years without the need to maintain any of the sensors within the unit. What that essentially means then in practice is that we can supply a vessel with a CCC gas detector, and for that full 3-year period, there's no need to intervene with it in any way, shape or form, giving that particular ship full autonomy, full control over their gas detection practices. And as well as that, complete transparency in the costing. You'll see later in the presentation that by removing the need to calibrate, to maintain, to replace certain aspects of the unit, you've just got one single cost and nothing else to forecast for the following 3 years. Throughout its lifespan, and it's not noted here, but it's definitely worth noting separately, the CCC unit comes with a full warranty. So again, peace of mind that that ship should know that there is absolutely nothing that they will need to spend, replace, if they adopt CCC for a full 3 years. And if that isn't enough of a benefit and isn't enough of an innovation, we've also got some of the bits of tech that the CCC can further enhance operations with. So it's got continuous data logging, customizability. So the unit can, via a PC connection with an IR link, be fully customized and have instantaneous access to the data that's been logged. It's got this usual highly rated ingress protection. So we've got IP68. It wouldn't be worth selling a detector into the industry that can't resist water. That would be a little bit silly. So we've got the right ratings in place in terms of its ingress protection, 1-button operation. So we know that crews, and this is feedback that we've had over the 10-15 years that we've been doing gas detection, they're wearing gloves, they're outside in the cold. It's not easy to try and navigate a nimble little device that needs multiple buttons to be operated. It's single button usage and doesn't need any training in order to be able to use it safely. And probably the final key feature in it that stands out, certainly to me, is its ability to work in zone 0 environments, so completely flammable environments. We know other options on the market only manage to gain a zone 1 classification, which is great, but if you've got an incident in a pump room on board a tanker and an individual needs to go in and inspect, you wouldn't be able to do so with a zone 1 unit because it wouldn't be intrinsically safe. The CCC is fully certified for use anywhere on board a vessel, so again enhances the protection that it can provide to the user. So sort of further elaborating on what I've just said, the benefits to the end users come via the fact that the unit doesn't need any intervention for a full 3 years. It's got its lifetime warranty, and there's no need to charge it neither. We've seen customers query in the past how they should be charging if the unit's going to need to be used on a sort of 24-hour shift pattern. When is their time to charge the detector? With the CCC, it's literally just a case of turning it on via that one single button, and it will run for a full 3 years. There's no need to turn the unit on and off. As well as all those great things, it's compliant, which is good to know. So it's got its full suite of MED and MER approvals that accompany the ATEX rating that I've just mentioned, meaning that it can be used on board international vessels. Both of these certifications that are referenced here at the bottom of the slide are internationally recognised and will enable a vessel to pass a vetting or a SIRE inspection as a result of those approvals being in place. So on to the exciting part then, the cost savings calculator. This is free to download from our website. We find it's a really great tool to use when organisations are looking at comparing their current solution to the CCC as a brand new offering. On this particular example, we've captured what we feel like are average costs for detectors. So you'll see that we've put in sort of 600 as the average detector cost, $100 per calibration, 250 for an O2 sensor, and so on and so forth. And what that calculates is that over a 3-year period, a traditional detector, with all its calibrations and with all the spares that's needed, the logistical costs needed to get the detectors to and from the vessel, you're spending on average $1,800 every 3 years. And if you take that even further, over a 6-year cost, $3,400. Compare that to the CCC, you've got 551 as your initial investment cost for the detector. And then if you were to replace after 3 years and look at it over a 6-year projection, just 1102 is your costs, and bring it down to the bottom here where you've got your savings. Even just over 3 years, over one lifespan of a detector, you're saving $1,249 per unit. So if you amplify that, and if you're operating or working with tankers, for example, that could have up to 10 personal gas detectors on board at any given moment, every 3 years you're saving $12,500, pounds, whatever currency. You're working in a fleet of 10 tankers, again amplifying it further. You've got £125,000, let's say, that you've saved over the course of 3 years, 250,000 over the course of 6 years, by adopting a detector that in most areas is superior when it comes to safety, accreditations, industry certifications, warranty, etc., etc. So you're not, by implementing the CCC, you're not losing any of the advantages that comes with a fancy multi-gas detector. You're gaining on that, and you're also gaining the savings that can be made. And for those that have joined and signed up to this webinar, there's a further 5% discount on the units themselves, meaning that savings are even higher at present.